Right, let's talk about implementing this. So an Apollo server is the standard server to deal with this. It's a plugin for Express, so it builds on top of Express, that builds up on top of Node. Apollo server needs two things to work apart from an Express server. It needs the type definitions that we saw last, and then it needs resolvers to actually have some code that does the thing. So if we look at that, we will see that the Apollo server, right, as I said, type definition and resolvers. So resolvers are functions, and they're actually methods on an object that I will show you later. But each of these functions or methods take 3 arguments, plus some extras that are rarely used. But they take a parent object, and parent objects are not always used. Parent objects are specifically for when you have a type that refers to another type, and then you can make a special resolver to load some of that lazily. So we'll see that later. The normal one is the one that's called args. I typically call it params because I like to refer to them as a parameter, but but they are properties. So they are properties for our arguments or parameters, if you like. And finally, we have context, which are server-wide properties that it's not something I have used in my examples, and it's also maybe not something that you need to use. But if you do need to know some server-wide properties, you can look them up in context. You can look up what it is yourself. So let's go and look at the. First of all, I just want to show you some helper functions. It's not a big deal, right? I have these 2 asynchronous functions because pretty much everything is asynchronous on the server. And one function is the respond with error, and the important part of the respond with error is that it can throw a new GraphQL error type. Right? So this is part of Apollo server, which means that if you throw a GraphQL error, it will translate. It will transfer to the client and actually come up as an error in the client. So that's one way of responding to something that's other than okay. And then we have the other one, that's the pending game, that I'm going to call in a while. But we'll see that it's a asynchronous function, so it returns a promise. Of course it does. It's pending game or undefined, and you might remember that in the pending game the return type did not have an exclamation point, right? So so that's why I'm saying over here, or rather because I can't guarantee that there is a game with an ID, it's undefined, and that corresponds to not having an exclamation point in the type. If I did have an exclamation point in the type and I tried to return undefined, I would actually get an error instead. Internal server error, I suppose. Okay. So this is how we define our queries. This is a property. You can see the syntax that this is a property of a large object. That's a resolve object. It has everything in there, which is why it's nice to sometimes put some of the code in other functions, because it's a big beast. So so for the query part, we have 4, but I didn't have room for the third. I think this is important part that we should see. It's not dependent game, that's the next one, but game is just kind of the same. You're just looking for games. You can see here I use underscore as a variable name for the parent because I don't need the parent. So this is the parent. For this particular thing, I don't need the parent. Games are not embedded in any large objects, so that is useless to me. But then you see, so here I did call them params because I do like that. But you can call them args if you like, it doesn't matter much. and saying, oh yeah, they have an ID that's a string, right? I guaranteed that in my STL, and also that ID actually had an exclamation point. And do note that I use string for the ID type. Then I call a method that returns a game. May or may not return a game. This is one of those that might not be there. I'm showing you both because look at this syntax instead. So there are some quality of life improvements that you can get away with writing stuff like this. I'm not sure you can do that if you have 2 parameters. I think it might only be 1, but you can try it. But anyway, it's the same. Mutation object. There's nothing new here. So that's the thing, right? You can go underscore any, and then you can go all of these params. And right, so we have two arguments or 2 parameters in our method, in the join method, and then it returns something. The more important part is, again, this is a property, and that property is an object, and these are methods in that object. You know about all the ways you can make method in JavaScript. You can also go and make a class, a mutation class with these methods, that then mutation would be : new mutation. That's also a possibility. You can just, all the ways you used to be able to make objects and methods and so on in JavaScript still work here. Let's talk about this resolver chaining. I talked about, I'm not using it because everything is one document in the MongoDB, so it doesn't really pay. But every game is one big document, so it doesn't pay. But here's an example for blocks and comments. Right? So a block has an array of comments. It doesn't matter what a comment is, but you know what a comment is. So those are blocks and comments. And one thing you could imagine if you are working on block software, that sometimes you want a front page or something that says, okay, this is a list of all blocks. No comments or anything, just a list of all blocks. And then you click on one of them, and then it shows a block, and then you want to see to load the comments at the end, or maybe even later. But I'm assuming that you want to load the comments at the end there. So then the query, your first query would be something like comments and well, ID. What else do we have? ID, text, so you can show some of it, date, maybe more, but no comments, right? And then later you would send a request like comment, not z, just what specific comment with ID, some sort of ID, right? And so on. So, yeah, okay, no comments. Okay, this was wrong. I did mean blocks. You get blocks without comments, and then later you get a single block that's with an ID and stuff and the comments. And the comments, then you would actually have to specify what you want from this. You definitely want the text user, something like this. Right. So you would like to be able to, what are we trying to do here? What we're trying to do is say, if I only get the text and a date, definitely don't send me the comments. But it wouldn't do that. That's Apollo server doesn't do that. But also, maybe you actually don't want to read the comments in the database, because why would I? So that's the idea. That's the idea that you're doing these 2 queries. So if we look at how that works, so we write the block. Oh, that's wrong. The blocks. We write the blocks in the query object, or rather the query property, the object that belongs to the query property, and there we write the resolver for the block query. And then we make a new block. So this is a property, and then this is a method in that object that the property belongs to, right? That gets the comments for the block. And the way this works is resolver chaining. So when I'm querying blocks here, I'm querying blocks. If I ask for comments in any way, if I ask for comments like I did in the previous slide, if I ask for comments there, when I ask for the one block, I ask for comments, then it will go and say, okay, we need the comments. Let's call block.comments, and that's when we get the comments from the database. Beware of one thing if you do this. Beware blocks. Okay, this may or may not be true. Actually, it could also just be block. Preferably it's only block, because if you're doing the blocks and you're doing some stuff and then you're doing some comments and then you're doing some stuff in comments, from comments, then what you're getting is, well, you're getting a query to get all the blocks, and then for each block it's going to go through and call block.comments, and block.comments is going to call the database. So you end up with n, if n is the number of blocks, right? So if we have n blocks, then we have n plus 1 DB queries. It's a common problem that shows up many places. Object or relational mapping is one of the notorious ones. If we try to do this, be absolutely sure you never ever want to do this. Absolutely sure. Because otherwise, n plus 1 database queries, you don't need a lot of those to actually completely kill your database server. So beware of this one. Right. Okay. Let me just, how do we write it? So we write this is just a function that I'm using later in the object, or would be if this wasn't a completely different example, but this code does exist. So block comment on a parent, and note, I'm not actually taking the args or params, and I didn't take the context in either of this. Remember, in JavaScript and also TypeScript, if you don't want a parameter, you just don't name it. Done. So we get the parent, and then we use the parent._id to figure out which blocks comments we want, because presumably the comments in this collection are pointing back to the parent. And then in the big resolver object, we make a block property, and that property has an object, and that object has a property called comments, which is this function. So that makes it a method. So another way of writing methods in JavaScript, you can do it all. Right. So that's one special resolver for resolver chaining if you need it. And other one is the type resolver that I did need, because a type resolver is something you need when a type can be ambiguous. So I showed you an interface that has two implementations. Now, if I look at data from this interface, then I would want to know How do I know? So that was a game. That could be either an active game, because active game implemented and a pending game implemented. So if I look at a game, is that an active game or pending game? And I will need some way to actually distinguish, because all I know is I have a game. In actuality, I didn't actually use that implementation. I used the union, but it's the exact same problem, right? If my game is a union of active game and pending game, and I'm looking at a game, how do I get to a union? You have to make these. So you have to make a type resolver, and a type resolver looks the same whether you are using interface implements or you're just using a union. It looks like this. So game. So this is also, this is the, again, right, this is the ambiguous type, the type that could be either two other types. You need one called underscore resolve type object. I suppose I could have said game there, but I guess I kept it simple. But object, if it's object depending, I return the name of the type. That's a string. So return the name of a string. In this particular case, this is what I have, right? This is for discriminating unions and so on. So that's what we're doing with it. Let me just show you some of this in context of larger code file. So what I want to show you here is mostly this large object that is, you can see it starts here. No, it's here. It starts here. The object that starts here is actually the resolvers object, and that has a query property and this query object inside. I showed you that, except for the, I guess, pending games. Mutation, same. I'm not sure why I inlined these two. They're probably better to do like this, because you can see that we are getting to a pretty big thing, and then we have my type resolver, and then something called subscription, but as I said, subscription is for next week. Now, so this is the context all of this is in, right? Then I need to use it. So what I do over here, there's a lot of boilerplate code. I'll try to highlight what you should pay attention to here. For instance, I am loading a file. That's the STL file that I showed you before. So I'm loading this file so it can actually read these type definitions. Here I create the resolvers object. That's actually just calling this method over here, returning this large object here. And some boilerplate code, some course that I showed you earlier, some more boilerplate code. I think the important part is that I'm making this executable schema, which is the entire point of having GraphQL. We have the type definitions, and then we have the resolvers, and when we put them together, we actually have a server that corresponds to a particular, that's this part, that corresponds to a particular contract, and that's this part. There's some WebSocket stuff that I haven't gotten into, so that's for next time. But then we have this is the Apollo server. I'm plugging in a server and so on. This is still boilerplate. All of this is boilerplate. And finally, I'm using the Express middleware to call the server. Well, I say finally. Finally, I'm actually starting the server and say listen on port 4000. And it could be anything, but that's port 4000. So a lot of boilerplate, but the important part is that's relevant for us here, right? We read the file, create some type definitions, create the resolvers, use that for it to make an executable schema that we then use in the use server so we can so we can actually run this. So I call it a subscription server, which is kind of a misnomer because it handles subscriptions, that again later, but it also handles completely normal request response GraphQL. So those are some implementation details. It is some you would need to look at the code when you code, because as I said, there's a lot of boilerplate here.